So we're going to take a look at a differential equation from the 2016 paper. So it's question 10a, and we're told that at time t seconds, the acceleration a of a particle is given by 8t plus 4. So acceleration in this question is a function of time. We're told that when the time is 0, the velocity of the particle is minus 24 meters per second. And we're interested in when this particle changes direction. So the actual question says, show that p changes direction only once. Now the way that we can do that is, if we can show that there was a particular time in the future when the velocity was 0, we'll know that for a split second the particle stopped, and then because the acceleration is a positive, it then began to move to the right. And so there was a change of direction at the point in time where the velocity v is equal to 0. So let's see how we might start this. So a is equal to 8t plus 4, and we know that acceleration is the change in velocity over time, so we can replace a with dv dt equals 8t plus 4. So here's our differential equation. We're going to collect the v terms on the left hand side and the t terms on the right hand side. So I have dv is equal to 8t plus 4 dt. I'm going to integrate both sides, and then I have to decide on what my limits of integration are. So in this case, the limits of integration are as follows. When the time is 0, we know that the velocity was minus 24. And then we're interested in the time when the velocity was 0. Remember that when the velocity is 0, that's the point when the particle changed direction. So integrating the left-hand side with respect to v, we get v. And integrating the right-hand side with respect to t, we get 8t squared over 2 plus 4t. And we can tidy the 8t squared over 2 into 4t squared. I'm going to sub in my limits, 0 and minus 24 on the left and t and 0 on the right, to give me 0 minus minus 24 is equal to 4t squared plus 4t minus 4 by 0 squared plus 4 by 0. Minus minus 24 is plus 24, and then the zeros cancel out at the end. And I end up with this quadratic equation. So 4t squared plus 4t minus 24 equals 0. I'm going to divide across by 4 to make the factorization of the quadratic a little easier. So t squared plus t minus 6 equals 0. And then factorizing this quadratic, I get t plus 3 on t minus 2 equals 0. Let each bracket equal 0, and we get results of t is equal to minus 3 and t is equal to 2. Obviously, t stands for time in this question, so we're going to discount the negative time, so we're not interested in that answer. And so t equals 2 is the only time when this particle had a velocity of 0, and hence that's the only time when the particle changed direction. And that's enough to prove it. The fact that you found a time when the velocity was 0, so remember, started moving to the left with a velocity of minus 24 meters per second, and then at some point its velocity was 0, and after that the acceleration is positive and starts moving the object to the right hand side, and so that's when it changed direction after 2 seconds. Now the second part of the question asks us to find the distance travelled by p between t equals 0 and t equals 3. Now the problem with this is we're interested in finding distance, which we're going to call s, but we have a formula that is a equals 8t plus 4. We can change acceleration into v dv ds equals 8t plus 4, but the problem with this approach is that we have 3 variables. We have v's, we have s's, and we have t's, and so that's not integration that we want to get into. So what we're going to do instead is we're going to make a formula for the velocity of the particle in terms of the time t. And the way we're going to do that is we're going to return to the differential equation, but instead of having a limit of 0, so we don't want to find the time when the velocity was 0 anymore, we're going to leave that as v, so that we can create a formula for the velocity in terms of the time. So we could return to this part where we've already done the integration and just instead of the 0 sub in a v. So that's probably the handiest thing to do rather than reintegrating it again. So if we skip on to that line, we can see that we have v minus minus 24 equals 4t squared plus 4t. And so if we bring the 24 over to the other side, we have the velocity is equal to 4t squared plus 4t minus 24. And we now have a formula for the velocity in terms of the time. Now the question is, why might this formula be useful in finding a distance traveled? Well, remember that the velocity is the change in the distance over the change in the time. And so we can change this velocity formula into a differential equation using ds dt. And that's what we'll do on the next page. So we have to be a little bit careful how we find this distance travelled between t equals 0 second and t equals 3 seconds. The reason being is that initially we moved to the left. We know that we moved to the left for 2 seconds. At that point our speed was 0 and we began to accelerate and move to the right. And we moved to the right then for 1 second. Now if we go and use a formula for displacement and sub in values for the time of t equals 0 and t equals 3, we'll find the displacement of the particle in those 3 seconds. And what that will give us is, it will give us a much smaller answer than we need, because distance travelled is different than displacement. The distance travelled is the full distance back to the point when he stopped and changed direction, and then the extra second that it took from the time t equals 2 to the time t equals 3. And so we're going to do two separate equations here using two separate sets of limits. So the first thing we're going to do is we're going to find a formula for this displacement. And the way that we're going to use that is we're going to use v equals 4t squared plus 4t minus 24. So the formula we created on the previous page. I'm going to change v into ds dt. And then I'm going to collect the s terms on the left and the t terms on the right to give me that ds is equal to 4t squared plus 4t minus 24. So the limits that I'm going to use for this differential equation are, I know that at the time t equals 0, obviously the displacement was 0. And then I'm interested in the displacement after 2 seconds. So again, the distance travelled in the first 2 seconds when they were moving to the left and before they changed direction. So integrating the left hand side with respect to s, I get s. And integrating the right hand side with respect to t, I get 4t cubed over 3 plus 4t squared over 2 minus 24t. So summing in the limits, I get on the left hand side s minus 0, and then on the right hand side I have 4 by 2 cubed over 3 plus 4 by 2 squared over 2 minus 24 by 2, and then subbing in 0 because each of the terms has a t in it, we'll just get 0. So s is equal to 32 over 3 plus 8 minus 48, and s is equal to minus 88 over 3. Now the minus 88 over 3 makes sense because it's a negative number and we know that the particle moved to the left initially. And so the magnitude of that displacement is 88 over 3. And that's the distance travelled in the first 2 seconds. We're now interested in the distance travelled in the third second, so from t equals 2 to t equals 3. So we have the same differential equation, we're just going to change the limits on the right hand side. And so the limits now are going to become 3 and 2. So rather than doing the whole differential equation, I can just return to this step and replace these limits here. So this will tell me the distance travelled in the third second. So on the left hand side I have s minus 0, and then on the right hand side I have 4 by 3 cubed over 3 plus 4 by 3 squared over 2 minus 24 by 3 minus 4 by 2 cubed over 3 plus 4 by 2 squared over 2 minus 24 by 2. So that gives us s is equal to 36 plus 18 minus 72, and we've already calculated this part of the equation here, and that was minus 88 over 3, and minus 88 over 3 is plus 88 over 3. So the distance travelled in the third second was 34 over 3, and that's this section of the journey here. So the question is, what's the distance travelled in the 3 seconds from t equals 0 to t equals 3? And so we're going to find the sum of 88 over 3 plus 34 over 3, which is 122 over 3. Now once again, just to emphasize, had we used limits initially of 3 and 0, so from t equals 0 to t equals 3, we would have found only this displacement here, the difference between 88 over 3 and 34 over 3, so which would have been much less than the actual distance travelled by the particle.